Hey everybody, I just want to walk you through real quick how to operate the Sparked model using the instructions on GitHub and cloning it into your environment, launching it from Docker, and then being able to plot some easy results after compiling the model, okay? So first, all I want you to do is navigate to this link right here, https://github.com/bertwhistlelab-sparked. Once you're there, you should see all the file dependencies for the Sparked model. Scroll on down to the instructions, and what you should find here is a link to Docker. If you have not installed Docker yet, go ahead and click this link and it'll drag you right here. Go ahead and install the Docker desktop app for your independent OS. And then come down to this first section where it says git clone recursive https github bertwhistlelab.git. Okay, all I want you to do is copy this, go into your particular command prompt app, or it could be called Terminal on Mac OS, or if I'm not mistaken, it is called also Terminal on Linux. Okay, so go into that environment. Don't worry about that command yet. Wonderful. We're going to go ahead and install the Spark directory inside of this downloads file, but what I want you to do instead is install it inside of a permanent directory. I'm installing it here to remove it later. All right, so all I want to do is just post this code, git clone dash dash recursive, that sparked link to github.git. All this is doing is it's saying clone or copy the repository from github.com and all of the files through this recursive tag into the current directory you're working at. Awesome. Once that's complete, go ahead and move into that directory, and what you should see is these right here. So you should also be able to do it from your GUI if you want, or your graphics user interface, by going to Downloads and then Sparked. Look at that. And then what you see in here is all of your Sparked environment information, such as your bin for all of your module folder, module commands, your input files for compiling the model, and the Jupyter Notebook files, which we'll use in just a second here. Okay. After that's done, all I want you to do is type in docker login, just like the command says right here. Now I'm already logged into Docker, but for what it should provide you is it's going to prompt you for your username and your password. Enter those in, and it'll log you into Docker. Wonderful. After that, all you're going to do is come down to the second command right here and say docker pull spark-notebook latest. Okay, what this is doing is it's calling the Docker package, and then the command within the Docker package pull, and then saying pull from the Docker environment bertwhistlelab the Spark notebook latest. That's going to install the Docker container with all of the dependencies to run the Sparked model under a Jupyter notebook. Awesome. Let's go ahead and click it. Okay, everyone. Once that's done, you're just going to come down here and copy this command right here, docker run on the port 8888 8888, which is, well, yeah. And then you're going to go ahead and name the Docker container that you want to run. In this instance, it's called test NB1, but you can name that whatever you like. And then initialize it with sparked notebook :latest. All right. Now, once this is going, you can either click it in this link here, and that'll get you up and running. Like I said, that'll get you up and running, and then you'll be able to operate within the Spark model. Alternatively, another way to do this is to use in the Docker environment. So as we saw those commands work, we can also do that within Docker. So if we wanted to clone an image, all we would have to do is go to the images section, and then let's get rid of this Burt whistle and search for it again, right? So if we just type in Burt whistle lab, it's going to be one of the first three things to pop up. We've got Spark Notebook and then latest. All I want you to do then is you're going to have an option to pull it here. So let's just click on this real quick. Now, normally if it's not running, you would see an ability to download it. So just go ahead and download it there. And then go over to container. And you should be able to toggle on and off or start and stop how you run this container by this actions button right here. Clicking stop will stop the container. Clicking start will obviously start the container. Wonderful. So let's go ahead and close that out because I probably just killed that action. Let's click on our container right here. And then all we have to do is either click one of these, or you should be able to, if I'm not mistaken, copy that to the clipboard, go to our browser, and then paste it in. See what we get. Whoops. Wonderful. So now we're operating in the Spark environment. What I want you to do is go to the Jupyter Notebooks, and then this create model file. This is going to compile the operation of the Spark model. Essentially, it's going to pull in all of the input files needed and compile an SBML model, which is like the recipe sheet for how the model is going to operate under the specific conditions you set. So we can see here, everything should look good. I want you to come up to this button right here. This button says restart and run all cells. It's going to ask for a confirmation. Just go ahead and click restart and run all cells. That will begin the compilation step of the model. Now note, just like normal Jupyter Notebooks, we're going to have star asterisks saying any task is pending. Wait for all of them to complete down at the bottom here. This should typically, if you've clicked that command and haven't reran any cells, be number 27 in the list. Anyways, once that star asterisk goes away and there's no error codes that pop up, you should be able to go ahead and start the Jupyter Notebook file run model. So let's go there next. All right, once the create model file is finished, we want to flip over to this run model notebook and we want to go to the required user input. So this is going to be the actual area that we input our simulation conditions, right? So this first one that we see flag D here determines whether or not the simulation is going to be deterministic or stochastic. Setting it 1 is equal to the deterministic simulation, and setting it equal to 0 is going to be stochastic. Then we want to set the simulation hours, or that's going to be within simulation time. The total simulation would be replicate of what your experiment that you're trying to replicate is going to be. Let's just set this for 1 hour for now. And then our stimulating conditions. So for these growth factors here, each one of these numbers corresponds respectively. So right now I have it set at 100 nanomolars for EGF and 1,721 nanomolars for insulin. The rest are all 0. Awesome. Okay. For you, all you have to do is basically change this file, this time, and then the stimulation conditions. Further, if you want to set the interval at which the simulation collects data or basically rechecks itself, you can set that here. Currently, it's set to 30 seconds, but this could be set to a minute or it could be set to 15 seconds. It's really up to you. But since I'm going to only run this for an hour with 30-second intervals every simulated, 30 seconds, we're probably only going to have about 120 data points in this plot. That's fine. So let's go down to our model simulation. Here we have our actual model simulation command. We have 3 variables that we've asked to output all results. Within the xout_s all file, we're going to have the results for our species or the protein and mRNA. Within xout_g_all, we're going to have the results for the genes within the model. And then at tout_all, we're going to have the time points, which is probably only going to be about 120 points long. And then finally, we're setting that equal to the run sparked command. This run sparked command can be found if we go back to the home section, then modules, we see run sparked. It's an internal command used to run the model, right? Okay, let's go down and look a little bit more. Here's where we save our results, and then let's look at the plotting functions. So as we recall originally, we say PLT is typically assigned to matplotlib.pyplot function. So let's go up and verify that real quick. And here we can see that we have imported the matplotlib.pyplot function as PLT. Wonderful. So then we go down and we see plt.plot, and that means that we're calling that package's plot function. And we're saying the x variable should be equal to this tt. Above, we've assigned tt to be equal to the time variables. And then for each one of those 120 points, we want to divide those by 360 to get how long it is in hours. If we go down here to this finished one, see how we only have it as 1 hour here? Let's change this real quick just so we can have a better example. I'm going to change this to in minutes now, since I've only simulated mine for an hour. And then here, this is going to be a really important one. This is where we plot our actual protein or species data. Here we've said, grab the species data that we've generated with this function here. And this is going to contain all 919 of these proteins listed at every single row. And we've said, grab every row, each of these rows. If we think of this as a rectangular data set right here, we have 919 columns by 120 rows. Those 120 rows are going to respond to the concentration of a particular protein at each time interval. And then we're saying grab all rows and grab the column 157. This 157 is going to correspond to the protein within this xout_all file. So let's look at what a particular protein might be. Let's say PBAD. Now note in this file that we're looking at here, we have a header and a couple of things that are throwing off the line count. I've done an evaluation just real quick ahead of this video to make sure that I know what that number is, and it's going to be 2 total spaces that aren't technically within that xout_all. Meaning that what we're going to see is that the number 157 is actually going to have PBAD on 159 in this document based on the interpreter. Not the end of the world though. Just keep that in mind. So here we have 159. Let's go back, or I'm sorry, 157. Let's go back 2 from 157 and we see PBAD right here, 155. Perfect. So we can say add 2 to 155, it should be 157. When we plot the results, that should be PBAD. Okay, so then what's the next one down here? Well, here we have 696. And if we say that that file is 2 behind whatever the number we set here is, if I wanted to see what 696 is, I would have to go to the row number 698. And we see 698 hyperphosphorylated AKT. That's pretty evident since we have this labeled free PP AKT right there. All right, so this is how you're going to set your specific protein sample. After that, to run this file, again, all we have to do is click the restart kernel and run all, and then confirm. And let's wait. Awesome. So now we've ran it, we've plotted it here, and then finally, what's not going to be in your file, and I want you to add into a new Jupyter cell by hitting Shift Enter in this one, is this plot.savefig command. And all I want you to do is save a file name for the particular species within the model that you've plotted. Great. And that's it. After that, we're done, and that should complete this assignment. Thanks, guys.